Well, hello and welcome to another MES tool release highlights video. And today we are going to look into the releases for fall 2022. We're going to look into the latest release of the MES Model Examiner, and I have Max here with me from the MXAM team. Hello, Max.
Hello, Jan. Hello, everyone.
So the latest version is the 8.2, and we have quite some interesting news for you. And I think we're going to start with a new check, and that's a generic check for the assessment of model metrics that can now be applied to a number of model metrics. But Max, maybe you can show us a little bit more what this check is about.
Yes, thank you. I think I will show you in the tool. I think you already know that we have a lot of numeric modeling metrics for our customers available in MXAM, which can be integrated in the analysis with modeling metric checks like our MES ARCH 301 or 1302, which will generate us a lot of findings for complexity metrics or other metrics in the model. And of course, you already know maybe that there are a lot of other metrics which are available for each analysis. So there's a very long list here. And in the past, it was only possible to check a few of them as MXAM checks. But now we implemented a new generic check, which allows our customers to check any of these metrics in an MXAM analysis in a very customizable way. And for that, we wrote the MXAM generic 1002, or rather MXWay generic 1002, which can be integrated in custom guidelines and then parameterized with bounds for warning levels and failed levels, and can be configured with any available modeling complexity metric available in MXAM right now. So I prepared a small example here, which includes the check, and then we have 3 parameters available, which configure the upper bound until which the metric will be assessed as passed. After that, it will be a warning, and then there's another upper bound, after which it will be failed. And of course, the string parameter, which is configurable with all the available metrics. So if we integrate this new check into our analysis, we now get additional findings. So for this example, we use the global complexity Rn, and also new findings in our MXAM report for any rule violations.
And if you go back to the metrics view, I think we can nicely see that we have configured the boundaries 1500, I think, as I remember, then it's a warning, and above 2000 it's a fail. So you can nicely see here the evaluation now for that additional metric from the generic check, right?
Correct. The color coding is also applied to the metrics table.
Very nice. And this basically applies now to any metric you would like to use, but we always recommend, of course, to create a guideline for that somehow states the purpose and the reason of the boundaries for these examples here, right?
Correct. But it's fully configurable, so a lot of freedom for our customers.
Right. Well, thank you very much for showing us that. And talking about checks, actually, this release, the check team worked a lot and had quite a large release of a large number of checks. Max, maybe you can tell us a little bit more what the focus was this time, and maybe you have also some highlights from the checks for us that you could show us.
Yes, thank you. You're right. This is quite a large release. I think it's one of the largest releases in regards of content yet. We have over 20 new or updated checks available, and we also had a focus on MAP 5.0 guidelines in this release. And in particular, we set a focus on Stateflow related guidelines and checks and implemented quite a few of those. And I would like to present a few of those Stateflow guidelines today. So I selected a few interesting guidelines, which I would like to show you now.
Yeah, that would be really interesting. Let's have a look.
All right, so I selected 4 different Stateflow guidelines for you today, and I would just like to go through them today with you. The first one is the JC 701, which is related to the usable number for first index. This relates to a very interesting problem, Vectors and arrays in Stateflow aren't either 0 or 1 based, but they can rather be configured individually to be either 0 or 1 based, and there is no consistent pattern enforced by Stateflow. So this can lead to very confusing scenarios where some vectors start with a 0 index, others start with a 1 index. And then there's also the confusion between C, which is sometimes 0 based, and then there's MATLAB, which is usually 1 based. So this guideline is created for the purpose that you can define a uniform base for all your vectors and check all Stateflow data items and also repair them.
Mm-hmm. So there's an auto repair also available for that check.
Yes. So the guideline comes in 2 versions, and you can configure the check with a parameter, selecting if you want to either have 0-based vectors or 1-based vectors, and then you will get findings for all the vectors which violate the setting. And you can also auto set all vectors which are not set to the correct value. Yes, okay, so then I have another check prepared, which would be or rather another guideline for which we created a check, which would be the JC762, which is about the combination of state actions and flowcharts in the same state. So here's an example of a state which just includes state actions, so entry and during in this case, and then another state which has a flowchart in it. And this rule relates to the combination of both those constructs in the same stage, which would be this example. So for a user, it would be confusing in some scenarios to understand what exactly is executed first. So for example, in the state A, we have a during action, which increments the variable T1, and also this flowchart, which increments the variable T1. And it's not really apparent which of these code sections is executed first. And especially if there would maybe be a condition which would be related to this variable, it's just not very easy to read and understand what the model actually does and when which code will be executed. So for this purpose, we created a new check, which analyzes all states and flags those which combine Stateflow, flowcharts, and state actions. And this should lead to a lot clearer modeling patterns if it is followed. Then another very interesting check, which I selected for you today, is the JC773, which is related to unconditional transitions of a flowchart, or maybe a bit easier to understand if we call it dead-end transitions. So this is related to transitions which go through intermediate junctions, and then some of the intermediate junctions could maybe not have an unconditional outgoing transition, which could lead to the problem where a transition is followed to a certain degree. So maybe in this example up to here, but then if there is no unconditional outgoing transition, the transition could get stuck and Stateflow would start backtracking through the transitions and try to find another way which would lead to this terminating junction. And this can get very confusing, especially if there are some transition actions or condition actions along this path, and then Stateflow backtracks through them, and the simulation state is just not very easy to understand for a developer, because what exactly happens if an action is backtracked. So we implemented a check which analyzes Stateflow flowcharts and finds those patterns and will flag any junction in those patterns which can be potential dead ends, if you like. So that was 3 different MAP guidelines, and we also developed one of our own new Stateflow Simulink related guidelines, which is called the Simulink Stateflow 1301. And this one is related to redundant condition actions. So a condition action, as you probably already know, is an action which is performed along a transition, usually, or not usually, always declared with those curly braces. And you can also implement them in a redundant fashion. So for example, here you would have 2 different transitions leading to the same destination, but they both have the same condition action, which is problematic if you later decide that maybe this action should be changed and maybe it's forgotten that it has to be changed somewhere else. It's no longer synchronous. There's just a lot of maintainability issues and also readability issues if those condition actions get long. So a better modeling pattern would be this example where both transitions join in an intermediate junction and the condition action is only specified once. So again, we implemented a check for this. And what's interesting about this check in particular is that it also involves a bit more complex repair action than we usually build. So this check can actually remodel parts of your state flow chart and enter those intermediate junctions, which I just described, to have a more efficient and easier to maintain modeling pattern, which is very interesting and was also very interesting to develop.
Ah, indeed. Well, it sounds like a very, very interesting guideline. Max, thank you very much for showing us this example here. I think we have a lot of topics that go into best practices and robustness of modeling. And so I think these could be really interesting guidelines for our customers as well. And we have the full list of all guidelines that are new, of course, in our release notes. So there's more. We don't have time to show everything today, but there's a list of what's new also in the release notes, right?
Yes, everything is available on our website.
We also not only have a number of checks that we showed you today, but there also has there's an added new feature that involves the queuing of license checkout, especially in automation environments. Max, maybe you can explain a little bit more about this use case.
Yes, thank you. That's also a very interesting new feature. This one is mostly targeted at our users which run their MXAM analysis on remote platforms. So for example, a Jenkins pipeline, which is triggered whenever an engineer pushes new models to something like a Git repository. Then you can have automatic execution of checks, which does not block the engineer's computer. And in this scenario, sometimes our users reported that if multiple engineers push models at the same time, or maybe one engineer pushes a lot of models at the same time, and those analyses should be run in parallel, so there is not such a long wait time for the developers. This could sometimes lead to a bottleneck with the amount of available MXAM licenses on the remote platform. So for this purpose, we implemented this new feature, which now allows the MXAM instance to enter an idle state if there's no license available, and it will be queued up and get priority on the next available license on the license server. So the analysis will just go into standby, and then a few minutes later, or whenever a new license is available, it will continue, and the pipeline will not get stuck or get any other license errors anymore. So this allows our users with the CI execution license to be a lot more flexible with how they use their licenses and make a lot more efficient use of the licenses they have available.
Well, that's also a very good new feature to enhance a lot of usage of MXAM also in this automation environments. All right. Well, thank you very much, Max, for joining me today. And of course, everybody is invited to check our website for the latest tool release requested via our website, or maybe you received our tool update newsletter, where you also have the download links for the latest version. And I hope to see you all soon again for our other news highlights for other tools, or latest for the next release, the winter release of MXAM. But for so long, Max, thank you very much for joining me, and goodbye.
Thank you for having me. Goodbye.